Hi everyone, welcome back to my YouTube channel. And today I'm going to discuss the all the seven problem. I guess seven, one, two, three, three. Okay, so all the seven problem of recent Division Three, recent Codeforces Round 895 Division Three. Okay, so yeah, the round was pretty good. Like all the problems are equal levels. I mean, not equal level. I mean, in perfect position. Like the A was very easy, and then B, then C, then D. Okay, so the perfect order. Okay, and let's just discuss the problem first. Like problem number A. So in this question, that like they given two vessel. Okay, so this is the vessel one, and this is the vessel two. So in this vessel, A gram of water is present, and in the second vessel b gram of water is present. Okay, so and what you can do is and there is another vessel, and in this vessel infinite number of water is present, infinity grams of water is present. So you can do one thing, that you can take c gram of water from this third vessel, and you can pour the water. Okay, sorry, I mean, okay, not like, okay, sorry, there are two vessels given. One vessel, in first vessel a grams of water is present, and in second vessel b gram of water is present. And what you can do is that you can take water from any one of the vessel. Like let's suppose I take the water from, let's suppose I took water from the first vessel. And what, like how much water I can take, at most here, you can hold up to c. Okay, at most you can see, like in one move you can take at most c gram of water. Okay, so if I want to take like 1 to c. Okay, so and also like the number should not be, like it is not mandatory that the number is integer. Okay, so the number can be float value, like 2.2 or 2.5, anything like. Okay, so you can take water from one of the vessel and pour into another vessel. And there is also like, okay, so you have to okay, in one move you can take at most c gram of water, and like from one vessel, and pour that into another vessel. And you have to tell them what is the minimum number of moves that the masses of masses of water in both the vessel are equal. Okay, so this is the question. And this is the pretty simple problem. Like, see, just take this example. In this case 3 gram of water is present, and in this case 7 gram of water is present, right? So uh, and at most you can take 2 gram of water from any one of the vessel and pour into another vessel. Yeah, so in this case you just have to tell minimum number of moves that required to make the water level, or water level in both the vessels same. Okay, so see, so now I am trying to make the water level in both the vessels same. So should I go with the first vessel? I mean, should I take the water from first vessel and pour it into second vessel? No, because why? Like obviously, like if I take water from this vessel and pour that water into another vessel, like the second vessel, then obviously this value is becomes less, and this value increase. But we have to make these two values same na. So that's why it is like always optimal to take water from the bigger vessel, like water from the vessel where the water level is more, or masses of water is more. So in this case we can just take water from the 7, like the second vessel, and pour it into another vessel. So how much water we can take, like that is also a case. So see, we have to, like here in this case we just have to minimize the number of moves na. So that's why we are trying to take as much as water from the bigger, like not the bigger vessel, the vessel where water masses of water is more. So we are trying to take the more number of water. Okay, like maximum number we can take from one vessel in one move is c grams. So here I just trying to take water from 2 gram of water from this vessel. So it becomes 5, and it becomes 5. So here see, in one move it becomes same, right? So yeah, like uh, just take another example. I think, yeah, like this is the problem, right? And there is one case, like every time you cannot find, like every time you won't find that level become like in integer moves. Like, okay, so let me I think this example is good. Okay, so just take this thing, this one. In this case, water like you can take like water mass or water level, anything you want to say. This is 17, and this is 4. So what I have said, that we it is always optimal to take water from the vessel where uh, the water level is more or masses of water is more. So, and always try to take as much as water. Okay, because that will help us to minimize our number of moves. Okay, right. So for that, here at max we can take 3. So here just remove 3 water, and if we remove 3 water, like it becomes 314, and it becomes 7, right? And this is the fast move, right? And in second move, this becomes 11, this becomes 10 in two move, right? So now see, the water level in both the vessel are not same right now, but we have to make the water level in both the vessels same. Like you can say that like mass or level, anything you want to say. Okay, now see, we need one more move, because in problem statement they have mentioned that you can like an empty cup can hold up to c gram. It is not like that ki exact c gram. Okay, so one, or you can take that like 0 point something to c gram. So now I require like here the maximum value is 1. Okay, so and we have to distribute this one to both the vessel. That means 1 by 2, 0.5, right? And just take 0.5 gram of water from this vessel and just pour this into this vessel. It becomes 10.5. Similarly, it becomes 10.5, right? So how much number of step we require? We require 2. Like number of step is 3. So like this is the simple problem, and another thing is that the constant is I mean low, pretty low. So you can do like there is no need to solve this problem in constant time. Yeah, like I have seen some of the like pro coders solve this problem in constant time. But yeah, like you can solve this problem in constant time, or you can just iterate like that. I have said that just take water from the bigger vessel, like the vessel where the mass of water is more, and take water from that vessel and pour into the smaller one. Take from bigger and pour into the smaller one. You can do that. That would be like at most we can, if we make 100 move, so 100 into 10 to the power 3, 10 to the power 5, so it run 5, right? So let's just take another example. Like, okay, so yeah, like this is the thing now. Like if you want to see the solution, then I can show that solution as well. I took a b c and answer is 0. This answer is number of step, minimum number of step. If a is smaller than, like I just want to make a is bigger. So if a is less than b, then swap a b. A is now a is bigger, and just move this thing until this condition is satisfied. A is greater than equal to b. And like in this case, that automatically handle that point case where I have told you like 10.5, 10.5. If you just dry on this case, then it will automatically fine. Because see that 17 and what is that example? Uh, just a second. 17 and 4. 17 and 4. 17 and 4. So this becomes 14, this becomes 7, and this becomes 11, this becomes 12. So now this is one move, this is one move, and after two move, now my A value becomes 11 and B value is 10. So we need obviously one more move. So yeah, like simply increase the answer plus plus, and if we increase the answer plus plus, I mean the answer is 0. And in, okay, so after this thing, answer value is 2, and again we count that because a value is greater than Now just make a minus 1 minus which 3, so which becomes 9 and it becomes 13. Now answer will is 3 and just out like come out of the loop. And you may ask that like bro, you are like not equaling the both the like masses of the water in both the vessel. Like it's just like you can consider that I'm like for the implementation, for the simplicity of implementation, like to make implementation more simpler, I did this thing, okay. But you can imagine that I did like in this way. After this position, to make the implementation simpler, I just did this thing like decreasing minus 3 and this and this. But you can imagine it in that way, that like in that way that I did 10.5. Yeah, like I'm doing 10.5 and 10.5. So like for the implement, like simply like to implement like, okay, to make the implementation simpler, I did this. So yeah, like this is the problem one. Okay, let's just move to problem B. I think this is like most weird problem. Like I don't know like why I took like 20 minute in this 20 minute. I guess yeah, I don't know. Literally, this problem is very easy. I mean, okay, so in this problem, what we are given is that okay. So let's just explain this thing. Where is that page marker? Yeah. So okay, so what we can do is that we can do one thing that just let's just solve this problem in later. Just solve C and D at first, C and D, and then we'll solve the B problem. Like it's quite. Hmm. Now C, number C. We'll solve B later. Okay. Mm, in the problem C. Okay, so in the problem C, you are given L and R, and you just have to find two positive integer. Positive integer, right? Zero. Positive integer means yeah, like 0 to anything. Non-negative. Positive. Okay, sorry. Sorry. I mean sorry. Positive means you are like not including 0, 1, 2. Yes. Okay, so basically you are given two integer L and R, and you have to find two integer A and B. But that two integers should satisfy the condition that these two conditions. I mean the greatest common divisor GCD of A and B is not equal to 1. That means obviously greater than 1. And the sum of the two integers should be lies between this the range lies between the range L to R. So yeah, like those two. Uh, if you are able to find these two number, then just print these two number. Otherwise minus 1. Yeah. So this is the problem statement. And here the range of the number is pretty large. But see, I think so. Just let's just think that how to think this problem, like how to solve this problem. We are given one range L, and this is R. Okay, and we have to find two integer. One is A, another one is B. Right? We have to find two integer. Okay, so first thing is that I cannot traverse for the all the element, because if I traverse for all the element, the range is 10 to the power 7 and 10 to the power 7 into 10 to the power 5. So it is like 5 into 10 to the power 9. This is the first thing. And another thing is that if you are able to traverse like all the array, then how you gonna calculate the thing, like for a number x there are a lot of number. I mean this is x 1, x minus 1, 2, 2x minus 2, uh, and L. This is R. Okay, so I'm like telling about x. So 1 and x minus 1, 2 and x minus 2. Now this is 3 and x minus 3. These are the possible number. Like if for a particular sum, these are the possible a and b value. Yeah, like I mean these values can possible. Na? So I mean like uh, Are you getting it? Like, does this making sense to you? Like thinking about something like constant time or something, because I cannot check for every number, and also the range is very large, and for every number or for every sum, also the range come like there are lots of possible values of a and b. So let's just think like, see, the problem is very easy. If we are find if you if any if any even number exists other than 2 in that range, in the L to R, first thing is that if L2 within L to R, if any even number exists and that is not equal to 2, then just divide that even number. Let's suppose the even number x exists between this thing, then a is equal to x by 2, and b is equal to x by 2, and obviously the x by 2 and x by 2. Now if the x value is not equal to 2, I mean, why I am saying like x value is not equal to 2? If x value is equal to 2, then 2 by 2 is 1, 2 by 2 is 1, and gcd of 1 and 1 is 1. So the second condition will not satisfy. So that's why we just have to find any we just have to find a even number other than even number other than 2. Because let's just take a even number case like 4, 6, 8. For 4 case, just find a is 2, b is 2, and gcd of a and b, like gcd of 2 and 2 is 2. And for 6, a is 3, b is 3, and gcd of a and b is 3. So are you getting my point or not? So this is the thing. Okay. And what if we do not have any what if we do not have any even number between that range? For that, like, the only case that we encounter is, see, if our range is 1 to 3, then in this case we do not have any even number, I mean, other than 2. And also if our range is 2 to 3, or 2 to 3, and if the value of r is less than equal to 3, then we do not find then we cannot find any, obviously, like there doesn't exist any even number who, like, other, like, greater than 2. So okay. But in other case, like, just take any range other than this range, like r value is greater than 3. Okay. R value is greater than 3. So if we take the example of like 4, 8, or maybe like 3 and 6. So 4, 5 exists. Now see, 4 is fine, 6 is fine. So you can take anything like 6. You can take 4 as well, and just do 4, like, you can take 4 and just divide, like, divide this 4 into two part. One is 2 and 2. The GCD of 2 and 2 is 2, and 4, like the sum of two number is 4, and 4 lies between this range 3 and 6. Okay. So this is the case. And mm, we just have to find the even number other than 2. But there is another case, that what about 7 and 7? If you take two consecutive number, just take two consecutive numbers, 7 and 8. No need to take bigger range. No need to think about. Okay, so if bigger range is given, then, like, obviously you can find two number. But like, just try to think about, like, in simpler way. Like, if we are given two consecutive numbers, 7 and 8, in that case also, we are going to take, like, we're going to take the 8 and divide the 8 into 2 part, 4 and 4, and a equal to 4, b equal to 4. Okay. So, like, this is the case. And if we are not able to find any even number other than 2, then what we'll do? I mean, I have told one case, like, okay, so the case one is, here the case one is that we are able to find the even number greater than 2, right? And the case 2 is that we are not able to find the even number, and um, even number greater than 2. And in that case, if our range is less than equal to 3, like, range means the, like, right hand side value. Range means we have L and R. If the R value is less than equal to 3, then at that case, like, just print -1, because 1, if we cannot divide like 1 into 2 in positive integer, and we can divide the 2 into 2 positive integer, but the GCD of this 2 integer is 1. And for 3 we can divide the 3 like into 2 integer, but the GCD won't be greater than 2. So just print -1 at that case. And there is just another like another case that the R value is greater than 3, but still we are not able to find uh, still we will not able to find any positive integer greater than equal to 2. This is the case 7 and 7. Okay, so can you say that in this case we print -1 or something? No, we cannot say anything about it. So okay, so in this 7 case you can say like, because 2 7 case, yeah, like in 7 case you can say that, yeah. But in this case you just have to print -1. But what is the case of 15? Okay, but in case of 15 you can find it, because bro, like see 5 and 10, 5 plus 10 is 15, and the GCD of 5 and 10 is 5. So how, like you cannot say like you cannot say like, okay, so if we are not able to find the even number, then just print -1. No, we cannot say like, the only you can say that if the like left right hand side value is less than equal to 3. Okay, but in other case you cannot say like like you cannot say like in 100% with 100% surety that you always print -1. For that case, just simple take the mathematical formula, like I just tell you that. Mm, okay, so you just have to tell A plus B. Okay, so like this is the only case that where L value is equal to R value, because uh, other than this, if you take any like any two consecutive number or any range where R value is greater than equal to R value is greater than 3, and the range is the number of element in that range is greater than equal to 2. In that case you always find a even number greater than 2. But this is the only case where L and R equal to, like L and R equal, and that is a odd number. So in this case, this is, let's consider the 5. Okay, so how are you gonna calculate answer for the 5? Like I just want to tell you the like simple mathematical formula that. Okay, so this is the concept. And now I just have to find like the GCD of A and B is something greater than 1. So if I consider GCD of A and B greater than 1 means, if this is A, this is K into A. Am I right or not? If the GCD of like, if the GCD of A and B is something like some positive integer greater than 1, then we can, like this condition is satisfied. This condition is satisfied or not? A is some multiple of, or like B is some, like it can be anything, like B is some multiple of A or A is some multiple of B. So here I am considering that B is multiple of K. Now this is 1 plus K into A equal to 15. Now see what we got. Well, now our number is the multiple of two number. From sum to we came to multiply. Now I think it becomes easy, because if we find A, I mean the sum of these two number, like the sum of these two number is 15. So that means I can say that A is equal to 15 by K plus 1, and 15 is divisible by K, because if 15 is divisible by K, then only this condition will satisfy. Okay, so now just iterate over all the divisor of 15 and just find, like if we find any number, like the number is A. Okay, so if you find a number, then one number is A and another number is uh, K minus 1. I mean see, for 15 one possible answer is 3 and 5. Okay, now just think that like 3 is your K plus 1, and this is your A. You can take like that. And what our initial number is a and k, so the number a and b will be 5 and ka. Here the k plus 1 value is 3. I mean the value of k is 2, and 2 into a, 2 into a is 2 into 5. The 2 into 5 value is 10. See, and if you are not able to find any such thing, okay, so if you are not able to find this thing, don't, like, just don't consider the, like, just traverse from the 2 to till like all the divisor except the number 1 and except the number 1 and the number itself. Are you waiting for now? Yeah, like, let's just see the solution. It is simple, I think. I just take these two values, and if I just find that if any number exists or not, then if the number exists, then I just print like by dividing these two number. And if that case, like the case that both the odd number are same, so in that case I just option 2, and this is I into I. So yeah, like I just did the same thing, that a and k type thing. Yeah, like this is the problem, this is the solution for the second, like third problem. And let's just discuss okay, so we'll discuss the fourth problem.